Hello, today I introduce Trustless Feedback, a protocol for privacy preserving an integrity variable RLHF. The motivation is simple. In the high-stake domains such as healthcare, precision engineering, expert feedback is extremely valuable, but now underlying data often contain private patient information or property design knowledge. Our core message is that contributors should not have to reveal the sensitive data in order to prove that their feedback is valid. The problem has two sides. First, there is a privacy barrier. Experts often cannot share raw data because of regulation or intellectual property concern. Second, there is an integrity problem. If the server cannot inspect the raw input, it also cannot know whatever the preference label was computed correctly. Existing approaches only partially solve this problem. Federated learning keeps the data local, but it can still be poisoned by dishonest clients. Differential privacy protect privacy, but noise can hurt utility and precision critical tasks. So the goal is to accept only valid expert feedback while revealing no raw private data. The key idea is to move the evaluation to the edge devices. The experts locally append the predefined evaluation function, E, to compare the two model responses. Then experts generate a zero-knowledge proof. This proof says, I used the connected evaluation logic, the hard safety concern passage, and the published preferences libraries correctly comparison result. The server receives only the label, the proof, and the hash of the evaluation function. It can verify the computation, but it does not see the privacy prompt, the candidate responses, or the intermediate scores. What exactly the proof verifying? Is a question. The paper formalized the expert evaluation as a function E. If the hard safety condition fails, the score becomes negative infinity. Otherwise, the response receives a soft utility score. The preference library is then just the indicator that response 1 score higher than the response 2. This can be instanted in different domains. In medicine, the hard consensus can check the prohibited drug combinations. In engineering, it can check the collision avoidance for the private CAD or PVC layout. The important point is that the server verifies the logic, not the underlying data. Finally, what is feasible? The protocol does not provide a full LLM fault path. It focuses on proving domain-specific constraint and the evaluation logic, which can be much similar. In the engineering validation example, collision checking can be represented with a simple arithmetic constraint, and the paper argued that this is the practical for consumer-grade devices on offline RLHF data collections. The takeaway is that the trustless feedback separates the verification from the visibility. The server can verify that the expert feedback is valid, while the expert kept sensitive data. This makes the approach especially promising for high-value, low-volume feedback in domains like healthcare, engineering design, and the other privacy-sensitive alignment setting. Thank you.